Welcome everyone. So student, we have already completed the explanation part of the lesson gravitation class 10th physics. Alright, so now today we will solve numericals, textual numerical, exercise numericals. Okay, so before solving the numericals, let's see first some of the formulae and the units which are required to solve the numericals. Okay, so let's see the first we will require the equations of motions. We know there are three equation of motion, and first is v is equals to u plus gt. Second equation is v square is equals to u square plus 2gs, where v is the final velocity, u will be initial velocity, and g is the gravity, and t will be the time required, and s is a displacement or a distance, or we can say height also. Okay, and third equation is s is equals to ut plus half gt square. Okay, and these three equation will be required to solve the numerical which are based on the free fall. Okay, and we know that in free fall the initial velocity will always be 0 because the object is at rest position. Okay, so u is equals to 0 only in case of a free fall. Okay, now next formula is f is equals to gmm upon r square. So this is a formula required to solve the gravitational force, to find out the gravitational force. Okay, you know na, Newton's universal gravitation force. Okay, so where f is a force, g is a universal gravitational constant, m is the mass of the earth, and small m will be mass of the object. Okay, and r is equals to distance between these two objects. Okay, now third formula is the g, small g. This is the acceleration due to gravity. Okay, so the g will be is equals to gm upon r square, where g is what, constant, gravitational constant, and m is the mass of the earth, and r is the distance. Okay, and fourth formula is weight. So formula for weight is same as that of the force. Okay, so weight will be equal to mg, mass into acceleration due to gravity. So student, you should remember all these formula to solve the numericals. Okay, now let's see some of the units which will require to solve the numericals. Okay, so because in the last after solving the numericals, at last we have to write the sentence. All right, and in sentence form we should write always the unit of each and every term. So here first term is velocity. This is the final velocity and initial velocity. So unit of velocity is meter per second. All right, and unit of distance is meter. All right, and unit for time, first symbol for time will be t, and unit is second, and force, it is Newton, and the gravitational constant is equals to Newton meter square per kilogram square, and the value of gravitational constant is a fixed value, that is 6.673 into 10 raised to minus 11. All right, and unit for mass is kilogram. This is so simple, and unit for weight is same as that of force, that is Newton, and unit for g, small g, that is acceleration due to gravity, is equals to meter per second square, and the acceleration due to gravity on the surface of the earth, its value is fixed, that is 9.8 meter per second square. Now student, let's solve numerical one by one. Okay, now let's solve question number 5. Solve the following examples from your textbook. So first question is, an object takes 5 seconds to reach the ground from a height of 5 meter on a planet. What is the value of g on the planet? So here we have to calculate the g, value of g, that is acceleration due to gravity. But student, if you will observe, if you will carefully read the question, then what is given, that object is there on a planet. Okay, so this is an object, this is an object. Okay, and the object will fall from the planet onto the ground, and it will take 5 seconds to reach the ground. That means here time is given as 5 seconds. Okay, and object takes 5, yes, from a height of 5 meter. So the total distance here, the height is nothing but the height or s, this is equals to 5 meter. Okay, so here we can use the equation, Newton equation of motion. Okay, now we will see which equation will be used. So here this is the example of free fall. So if you will remember, just now we have seen the three equation of motion, that p is equals to u plus gt. So in this question here, the value of s is given, all right, and t is given. Okay, so we will use this equation. So from by this equation we can calculate g. So we will use third equation of motion. Okay, now let's solve it. Here initial velocity in the free fall, it will be always 0 because object is at rest position. All right, so u is equals to 0, s or height is 5 meter. All right, and time is given as 5 second. All right, so here we will write one sentence that suppose acceleration due to gravity. Okay, acceleration due to gravity is g. Here we are supposing that g is acceleration due to gravity because we have to find out this only. Okay, and we will take the equation as third equation of motion. Okay, because all the values are given, we can easily find out the value of g. S is equals to ut plus half gt square. Now let's put up all the values in the equation. S is given as 5 meter, u is 0, multiplied by time is given as 5 second. Okay, plus half, g will be as it is, and time is given as 5 the whole square. Now it will be 5 is equals to 0 plus here 5 square will be 25 upon 2 g. Okay, now what we will do, we will keep the g one side and all the numerical value on the one side. Okay, so here it will be g is equals to 5, this 2 will go here, 5 multiply by 2 upon this 25 will come in the denominator. Okay, so now let's cancel it, divide it. 5 ones are 5, 5 5s are 25. Okay, so here g is equals to 2 upon 5. Now again it will can be divisible by 2 and 2 by 5, so it will be 2 ones are 2. Here 5 is there. Okay, so 5 is there, so it will be, okay, sorry, so this will be 5 ones are 5 and we know 5 fours are 20, so here it will be 0 0.5 fours are 20. Okay, so it will be 0 0.5, so the value of g is 0 0.4 meter per second square. So here you can write this sentence, write the answer in the sentence. Value of g planet is, value of g on the planet is 0 0.4 meter per second square. So this is how we solve question number A. Okay, so question number B is the radius of a planet A is half the radius of the planet B, and if the mass of planet A is ma, what must be the mass of B so that the value of g on value of g, that means acceleration due to gravity on B, is half that of its value on A. Now here what is given, first of all radius. Here none of the value is given, but here radius is given and mass is, we have to find out the mass of planet B. Okay, that means here we have to find out the two objects A and B. So what we will do, and g is also given here. Now g is not given but g is mentioned here. So what we will do, we will use the formula of acceleration due to gravity and we will compare the formula with both the cases, that is in case of object A also and in case of object B also. Okay, now let's first write down all the conditions which are given in the question. So here we will what is given here, first we will draw the rough diagram. Here this is object A and this will be the object B. Okay, so here radius of, here mass will be here ma and its mass will be mb. Okay, so here radius is given, radius of a planet A is half that of radius of B. So here this is a radius, so radius will be r upon 2, and here the radius will be r. Okay, and next it is given as if the mass of A is ma and mass of second will be mass of B will be B. Okay, so what must be the mass of B so that the value of G on B is half that of its value on A. That means here it will be G upon 2, half of A na. So A will be G, then value of B it will be G upon 2. Now let's solve the question. Okay, so here we will compare it by two cases for planet A, and here we will write for planet B. Okay, so for planet A the radius is r upon 2, all right, r upon 2, and for planet B radius will be equals to r. Okay, and for planet A mass is what, ma, and for planet B mass will be mb. Okay, and value of acceleration due to gravity, here I am writing in short form, acceleration due to gravity. So here GA, value of GA will be G. Okay, on the object A the acceleration due to gravity is G, and for object B, that is GB, it will be half that of A. That means for A is G, so for planet B it will be half of G, that means G upon 2. Okay, now we will just apply the formula. Here I am writing with blue pen so that you all can understand. Here the formula G is equals to Gm upon R square. I am doing the partition, and G is equals to Gm upon R square. Okay, so let's, here G will be same because this is a gravitational constant. Okay, so it will be m. What is mass of A? It will be ma. All right, and the radius value is r upon 2. So here we will write r upon 2 the whole square. Okay, now solve this only. So we will get G into ma. Here r upon 2 na, so the square it will be r square upon 4. Now this 4 will comes into numerator, so GMA multiplied by 4 upon r square. All right, so our final equation is, that is GA is 4 GMA upon r square. Suppose this is our equation number 1. Okay, now let's solve for GB. So here it will be G is equals to G of MB. Okay, and here GB is G upon 2. All right, so GMB upon r square will be same. Here radius is r only, so we will write here r square only. Okay, now G will be as it is at this side only, GMB multiply by this 2 will comes here, so it will be multiply by this upon r square. So let this will be our equation number 2. So this is equation number 1 and this is equation number 2. All right, GB. So okay, now equate both the equation. Okay, here I am writing equating equation 1 and 2. All right, so we will get equation 1 is what, 4 GMA upon r square is equals to twice of GMB upon r square. So what we will do, we will first cancelling the terms which are similar. Okay, so here G and G will get cancelled, and this r square and r square also will get cancelled. Similar term will get cancelled. Okay, and here 2 ones are 2, 2 twos are 4. So what will be the remaining term? Twice of MA is equals to MB. Okay, so just rearrange the term, that MB is equals to twice of MA. So this is what we have to prove, na? Because here it is given the mass of B, so that the value of what must be the mass of B. So here we have calculated the mass of B is equals to twice of ma. Alright, so this is how this question to be solved. Okay, now let's solve question number C. So question number C is the mass and weight of an object. Okay, mass and weight of an object on the earth are 5 kg and 49 Newton respectively. Okay, and what will be their values on the moon? Assume that the acceleration due to gravity on the moon is 1/6 of that on the earth. So here what is given? Mass and weight of an object on the earth are given. Okay, so weight of an object on the earth is 5 kg and weight of an object on the uh, moon, it is sorry, weight of an object on the earth is given 49 Newton. Okay, so here we have to calculate both the values, that is mass and weight on the moon, and assume that here acceleration due to gravity is given. Okay, so first we will use the formula for weight, that is W is equals to mg. All right, but here student, if you will remember my that video on mass and weight, so mass of the object on every planet, it will be constant. So here mass of the object on the moon, it will be same as that of the earth, so mass will be same 5 kg only, and here weight of the object on the earth is 49, but we have to calculate the weight of an object on the earth because weight is continuously changes, it will be okay, weight will be changes but mass will be same, that is 5 kg. Okay, so here mass we will not calculate, we will calculate only the weight of an object on the moon. So let's start solving. Okay, so here first we will write all the conditions. Okay, so question number C I am solving. Okay, question number C. So on earth, so here two planets are there, here earth and here it is moon. All right, so mass is given on earth is 5 kg and weight of an object on the earth is 49 Newton. So here mass we have to calculate, but it will be same because we have studied that mass of an object on every planet place to place, it will be constant, so it will be 5 kg. And weight we will find out by the formula. Okay, now let's start solving. So on earth mass is equals to, that is m is equals to 5 kg and weight W is equals to 49 Newton. Okay, so here we have one formula for weight, that weight is equals to mass into acceleration due to gravity. All right, so here weight is given as 49. All right, so mass is given as 5. So by this formula we will calculate the acceleration due to gravity, that is g. So what will be the value of g? G will be 49 upon 5. Okay, so after solving it will be 5 ones are 5, then 5 nines are 45. All right, 5 nines are 45, remaining will be 4. So we will apply here, we will put here decimal, 40, 5 8s are 40. So what is the value of g? So value of g is 9.8 meter per second square. Okay, so we got the value of g. Now here we will calculate the acceleration due to gravity on the moon. So why we will calculate here? This is because this we have to use in the formula for weight. All right, so acceleration due to gravity on the moon is 1/6 of earth. Okay, so 1/6 multiplied by 9.8. So after division we will get the answer as 1.634 meter per second square. Okay, so this is a value on g on moon. All right, so now we will calculate the weight on moon. Weight on moon. All right, so formula for weight is equals to same, so mass is same, that is 5, and acceleration due to gravity will be 1.634. now let's solve it. Let's do multiply. 5 4 is the 20, 15, 17, 5 6 are 30, so it will be 31 5 ones are 5, 8. Okay, 8.170 Newton. So 8.170 Newton. This is a weight on, here I am writing the moon. Okay, so here we will write one sentence that mass of an object on any planet remains same or constant. So it will be 5 kg on moon and weight will be equal to 8.170 Newton on moon. Alright, so here this G, it will become minus. Why? Because ball is moving first upward, then it coming back towards downward direction. Okay, so this will be minus. So here all the data after moving toward this side, it will become 2 multiplied by this thing. Okay, so again 0, 2 5s are 10. Alright, so our u, that means here u square is 10,000. So our u will be equals to square root of 10,000. So u is equals to 100 meter per second. Okay, 100 meter per second, not square, per second. Now let's calculate the time. Okay, now here we will calculate the time by using Newton's first equation of motion. So Newton's first equation of motion is equation of motion. So this is v is equals to u plus at. Now this is so simple. V's value is given as 0. Initial velocity we get as 100. Here g will come and value of g will be again minus 10, and time we have to calculate. So what we will do, this minus 10t will come this side, so it become plus is equals to 100. So t is equals to 100 upon 10. So therefore t is equals to 10 seconds. Okay, so here by this we have calculated initial velocity as 100 meter per second and time required to the object to come back towards the earth, it required as 10 seconds. Okay, now let's see question E. Okay, so what is question E? A ball falls off a table and reaches the ground in 1 second, and assuming g is equals to 10 meter per second square, calculate its speed on reaching the ground on the height of the table. So here what is given? A ball falls off. That means first ball is at table. Okay, here it is a ball and it falls off in 1 second. That means here t is equals to 1 second, and here initial velocity will be 0. Why? Because the ball is at rest position and on the table. Okay, and what is given here? Further, calculate its speed on reaching the ground. That means on reaching the ground, here after reaching the ground, its speed we have to calculate. That means we will calculate here final velocity. Okay, that means we have to calculate, and also the height of the table. Now here height of the table, that means the distance of the table from the towards the ground. Okay, so here we have that means height is nothing but the distance only. Okay, so these two things we have to calculate in your final velocity and distance, that is s. Now let's first we will write all the given data, that u is equals to initial velocity will be 0 and time is 1. Final velocity we have to calculate and distance we have to calculate. Okay, g is given as 10 meter per second square. Okay, now what is here? Now what we will do, as we have did in question D, we have used two equation of motion. Okay, so here also we will use equation of motion as first equation of motion, that is v is equals to u plus gt. Now we have to calculate, and value of u, initial velocity is 0. Okay, and g is given as 10 and time is 1. So what is v? It is value of v is 10 meter per second. All right, so here we have calculated the value of g as 10 meter per second. All right. So value of G is 10 meter per second. And next we have to calculate what? Distance. All right. So for distance we will use, first of all here we will write here as height of the table equals to what? Is equals to distance only, and distance is denoted by the letter S. Okay, so here we will use the equation of motion, that S is equals to ut plus half gt square. Okay, ut plus half gt square. Now let's put up all the values in the equation. So here again here I am writing S is equals to ut plus half gt square. So as we have to calculate, u is given as 0 and time is 1. Okay, 1 second. So half value of g is 10. Again t will be 1 square. So here 2 5 are 10 and 1 square will be 1 only. So s is equals to 5 meter. So what is the height of the table? It is 5 meter. All right. Alright, so question F is, the masses of the earth and moon are 6 into 10 raised to 24 kg and 7.4 into 10 raised to 22 kg respectively, and the distance between them is 3.84 into 10 raised to 5 kilometer, and calculate the gravitational force, that is F, gravitational force of attraction between the two. So here we will use the Newton's universal law of gravitation. Okay, so here mass of the earth and moon is given. So mass of the earth is 6 into 10 raised to 24 kg and that of moon is 7.4 into 10 raised to 22 kg here. Okay, and the distance between them is given as 3.84 into 10 raised to 5 kilometer. Okay, and we have to find out the gravitational force of attraction, that means F is equals to question mark, and the value of G. Here first we will write the formula. Yeah, okay, so first we will write the mass of earth given data. First, mass of earth is 6 into 10 raised to 24 kg and mass of moon is 7.4 into 10 raised to 22 kg, and the distance, so the distance is denoted by r. R is 3.84 into 10 raised to 5 kilometer, and for the formula is here what is given here, r is given in the kilometer. Okay, so first we will convert them into meter. So how it will be converted? It will be multiply by 1000. So 3.84 multiplied by 10 raised to 5. Now this 1000 can be written as 10 to the power 3. Okay, so here I am writing as multiply by 10 to the power 3 meter. So therefore r is equals to 3.84 into, now here the base is same, so indices will be, power will be added. So 5 plus 3, it will be 10 to the power 8 meter. Okay, so here we have converted kilometer to meter. All right, so now let's write the formula, that F is equals to GME m upon r square. Now let's put up all the value. Now value of G, it is gravitational constant. So value of G is 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. Okay, now let's put up all the value in the formula. G is 6.7 into 10 raised to minus 11, and mass of earth is 7.4 into 10 raised to 22 kg, and mass of moon is, sorry, it is 24. 3.84 into 10 raised to 5 upon distance is 3.84 into 10 raised to 8. Okay, now what we will do, we will write all the numbers, that is 6.7 into 7.4 into 3.84. Sorry, here 3.84 will not, this is a distance I have written, and it will be 6. All right, it will be 6, not 3.84. Okay, so this is 6. All the thing we will write together, and the power, that is 10 raised to minus 11, 10 raised to 24 multiplied by 10 raised to 5. We will write it together, and this is square. Okay, so square, it will be written as 3.84 multiplied by 3.84 multiplied by here 10 to the power 8. So 8 square, it will become 16. Not 8 square 16. 8 to the 16. So here we will write 16. Alright. Now after multiplying these things, okay, this that is 6.7, 7.4 and 6. So it becomes 297.48. Okay, 297.48. And after doing this, that is first 24 minus 11 and plus 5. So the power becomes 19. So 10 to the power 19. And in the denominator, after multiplying this 3.84 and 3.84. So here I am writing the same thing, 3.84, 3.84. Now here 10 raised to 16. Okay, this will becomes also 10 raised to 16. All right, so this 10 raised to 16 will go into the, sorry, 10 raised to 16 only I am writing here. Now after solving all the things, we will get answer as 20.17 into 10 raised to 19. All right, now here 10 raised to 19 is there. So what we will do, we will just arrange our answer. We will just shift this decimal after one digit, that is 2.017. So here it becomes 10 to the power 1 only. Okay, and 10 raised to 19. So our answer becomes 2.017 into 10 raised to 20 Newton. All right, so I hope you all will do can do the calculation part by yourself. Okay, so this is how we solve question number 6. Okay, now let's solve question G. So question G is, the mass of the earth is 6 into 10 to the power 24 kg, and the distance between the earth and the sun is 1.5 into 10 to the power 11 meter. And if the gravitational force between the two, that is earth and sun, is 3.5 into 10 to the power 22 Newton, what is the mass of the sun? Now here question number F and G are same, but here gravitational force we have to calculate, and here gravitational force is given, and we have to calculate the mass of sun. Okay, now let's start solving. First I'm writing here, I will make the rough diagram. This is sun. All right, so earth, this is earth. So mass of the earth is given, that is me is 6 into 10 raised to 24 kg, and the distance between the sun and the earth is 1.5 into 10 to the power 11 meter. And here gravitational force is also given. First we will write all the given data. So for gravitational force is 3.5 into 10 to the power 22 Newton. Mass of earth is given as 6 into 10 to the power 24 kg, and mass of sun we have to calculate, and the distance, okay, the distance is given as, sorry, distance is given as 1.5 into 10 to the power 11 meter. Okay, so now let's first write formula. F is equals to GME, mass of the sun, upon R square. So gravitational force is given, force is given as 3.5 into 10 to the power 22 Newton. Now, the value of gravitational constant, it is 6.7 into 10 to the power minus 11. And mass of earth is given as 6 into 10 to the power 24. Mass of the sun we have to calculate, and distance is 1.5 into 10 to the power 11 square. All right, so now what we will do first, we will solve this side only. This is 0.7 into 6. Now 24 minus 11. Okay, 24 minus 11, it will be 10 power 10 upon it, 1.5 square, na? So 1.5 by 7 to 32. All right. Now what it is 6.6. Now after multiplying, we'll do here mass into mass of the sun. So mass of the sun comes this side, and we will shift all this data towards the left hand side. All right. So now here it will be 5 into 10 to the power 22. Multiply this thing will come here. Numerator 5 into 1 5 into 10 to the power 22 on this numerator in the denominator 6 into 10 to the power 13. All right. Now this 5 22, and here okay, so 3.5 multiplied by 1.5 and 1.5 it will become 2.25 because square of 15 will be 225. Okay, now here 10 to the power 22 22, so it will be 22 plus 22, it will be 44. Okay, and here it will be 6.6 6.7 multiplied by 6, it will be 40.2 into 10 to the power 44. Okay, now what we will do here, after first we will do the power part. Okay, 40.2. now here this, so here it is 13. Okay, so now here 44 minus 13, so it will become what here positive na, so after comes in the numerator it will become negative. All right, so 44 minus 13 it will be, now after solving this, after calculating this thing, it becomes 0.196 multiplied by, now 44 minus 13 it will be 10 to the power 31. Now what we will do, our answer is 1.96, so we will shift the decimal 1 point before, so it become 1.96, sorry 1.96 10 to the power 30 kg. Okay, now here we will do the minus 5 because the we are shifting the decimals 1 point before. Okay, so it becomes 10 to the power 31 kg. So this is our mass of the sun. So student, I hope you all have understood the numerical part. Thank you all of you.